Well, this is a joint paper with Luigi Filippini, which is a colleague of mine at Università Cattolica del Sacro Cuore in Milan, and Debapriya. This is a very simple paper, basically. So this is not a general model. It is a very simple model. Basically, what we do in this paper is to introduce capacity constraint into a standard linear demand Cournot duopoly licensing game. So basically what we do now is to consider a classic standard licensing duopoly game, and then in this game we introduce a capacity constraint patentee. Okay, so I apologize in advance whether I will be quite short in this presentation, so probably I will not need to use all the time that I have, but the paper is simple and the model is simple too. So what we do here is to consider the problem of patent licensing in a Cournot duopoly in which the innovator, the patentee, is one of the competing firms and it is capacity constrained. So here we introduce a parameter, which is the level of capacity constraint. When the capacity constraint is maximum, so which means that the patentee cannot produce, okay, so the quantity that can produce by the patentee is a 0, then it is the same like having an outside innovator, okay, because the patentee cannot produce. When a capacity constraint is not binding at all, it's never binding, then it is the same to have the case of an inside innovator. So what we aim to do is basically to provide a bridge between the two models which are usually considered in the literature. So the case with an outside innovator and the case with an inside unconstrained innovator. Here I'm talking here about process innovation, not product innovation. So the innovation we have in mind here is an innovation that allows reducing the marginal cost of production. Why we introduced this novelty into the literature? Because there is evidence of the importance of small firms in generating technology innovations, which are diffused by means of the licensing. For example, there is this quotation from the OECD, which says that, well, innovating firms lack the complementary assets, such as marketing and manufacturing, which are necessary to successfully commercialize their inventions. So basically, what it happens sometimes or often is that the innovating firm is a small firm, so it is likely to be capacity constrained. So what we want to model is exactly this situation, a situation where the innovating firm is capacity constrained. Here we have some historical evidence from Pavit et al. They analyzed the size distribution of innovating firms in UK after the Second World War, and they show that smaller firms are more likely to commercialize innovation than bigger firms. Basically, when we have small firms, it might be that the firms is not able to produce all the quantity that it would like to produce. This is a situation where we might have capacity constraints. So this is the starting point. The starting point is that, well, the innovating firms might be small, and so it might be that the capacity constraint is a relevant part of the story. What is quite surprising is that the theoretical literature, I mean the patent licensing theoretical literature, has rarely considered the role of capacity constraint in determining the optimal licensing scheme of the patentee. There are very few exceptions. To the best of our knowledge, there are just two examples. One is a working paper by Eva Scholz, 2017, which were very different from our paper, from our model. It is a vertical channel models where the licensee is capacity constrained and not the patentee. And a note by Marco Derighi in 2008, where it is assumed that the licensing scheme is such that the patentee allows the licensee to produce a certain quantity. So which means that it is the licensee again that it is capacity constrained, and not the patentee. what we do here is what we consider here is a situation where it is the patentee to be capacity constrained. Furthermore, our work is somehow related to those papers that considers the case of decreasing return to scale. Debapriya and Georgios Stamatopoulos has written many papers on this. I jump to the result and then I will move back to the model. The main result we have is the following. It is well known in this kind of a literature, then if you consider optimal patent licensing from the point of view of an outside innovator, then it is often true that the preferred mechanism for the patentee is fixed fee. This dates back to Kamin and Tauman 1986. There are many other papers that show that in many situations, for an outside innovator, it's better to licensing by means of a fixed fee rather than a per unit royalties. With an inside innovator, at the opposite, per unit royalty is often better than fixed fee. There is the seminal paper by Bang that has been generalized by Sen and Tauman and others. What we show here when comparing fixed fee and per unit royalties, we show that fixed fee is preferred by the patentee, even if the patentee is an insider, but provided that the capacity constraint of the patentee is strong enough. And this happens both in the case of drastic innovation and in the case of non-drastic innovation. So this is the main result. What we do is to compare, as usual in the literature, these two types of licensing methods, per unit royalties and fixed fee. What we showed is that even if the patentee is an insider, then you might have that fixed fee is better than per unit royalties, provided that the capacity constraint is strong enough. This happens for both drastic and non-drastic innovation. When we move to consider optimal combinations of
so one second, if the capacity constraint is not strong, I'm looking at your second point, then is the opposite true, that royalty is better?
When the capacity constraint is not strong, then per unit royalty is better. But in the case of drastic innovation, if the capacity constraint is very strong, that's not licensing is even better. Okay, here I'm just talking about the comparison of the two licensing schemes. Then at the end I will show a picture where all the results are summarized. Here I'm just referring to the comparison of these two types of licensing schemes.
Yeah.
When we consider
for the definition of drastic innovation, maybe people don't know. Is that,
yes, okay, yes. Later on, I will provide the definition of this. Basically, in this simple model, we have drastic innovation when the original marginal cost is high enough, basically. Okay, and in the case of optimal combination of fixed fees and royalties, our main result is that there are many situations where the optimal royalty is lower than what we have in the standard case, so without no capacity constraint. These are the main results. So they're very simple after all, and because the model is simple too. And then I will move to describe the model. But before describing the model, I would like to stress that here we are not considering all possible licensing schemes. There is an increasing literature on other type of licensing schemes like ad valorem royalties or profit sharing royalties that under some situation might be better than traditional schemes like fixed fee or per unit royalties. So we are not considering them. So it might be that there is even other type of licensing methods which is even better than this one. Okay, so what we are just focusing is on fixed fee and per unit royalties and combinations of them. So this is the model. The model is just the simplest one. It is a Cournot duopoly with two firms, so firm 1 and firm 2. Let Q1 and QB and Q2 be the quantities produced by 1 and 2. There is a linear inverse demand function, so the price is equal to 1 minus Q1 minus Q2. Firm 1 is the patentee, and it has a cost-reducing innovation. The marginal cost of a firm is 0 with the innovation, and it is C between 0 and 1 without the innovation. Well, the novelty with respect to this standard model is that firm 1 is assumed to be constrained by capacity K1, by capacity K. There was my baby right there that was calling me. Okay, and so firm 1 is constrained by capacity K strictly greater than 0. And firm 2 has no capacity constraint.
Why is that? Why is the firm, I mean, more general would be to give both of them capacity constraints and let the second one be a large one.
Sorry, yes, we're not assuming that firm 2 is capacity constrained.
I'm saying why? The more general case would be to assume capacity for both, yes, and then let one capacity be relaxed to infinity. That's the more general model.
Yes, I agree. There are many ways in which this model could be generalized. This is one of the models. This is one of the points through which this could be generalized. Okay, we are just keeping as simple as possible the analysis. So by assuming that just one of the two, and the patentee is capacity constrained, yes, you might say that also the other is capacity constrained, but K2 tends to infinite, right?
Right. This is what so I'm saying. Do you need that K2 equals infinity, or you can make K2 large? That's what I'm asking.
Well, I think that we might just assume that K2 is sufficiently large.
Okay.
Okay. Here for the distinction between drastic and non-drastic innovation, for those that were not familiar with this kind of distinction, let's consider a monopolist which is facing a linear demand, so price 1 minus Q, which is the overall quantity which is produced by the industry, who is not capacity constrained and who has the cost reducing innovation, so its marginal cost is equal to 0. Well, the monopoly price and the marginal cost equal to 0 in this case is 1 divided by 2. And the following arrow, cost reducing innovation is said to be drastic if the monopolistic price is lower than 1 divided is lower than C, the marginal cost, which is in this case is 1 divided by 2, and it is said to be non-drastic if the marginal cost is sufficiently low with respect to the monopolistic price. So what you have is that for a drastic innovation in the standard case, so without capacity constraint, if firm 2 does not have a license, it drops out from the market. But if firm 1 is capacity constrained, firm 2 might have positive profits, even in the case of drastic innovation. And this is summarized in the following picture. So here you have the situation where firm 2 has not the license, and these are the profits of firm 2. Basically, what you have is that in the case of non-drastic innovation, the left side of the picture, firm 2 clearly has positive profits because innovation is non-drastic. In the case of drastic innovation, if the capacity constraint is strong enough, then firm 2 has still positive profits, whereas it has 0 profits if K is sufficiently high, so that the capacity constraint is not relevant. Okay. Now let's consider the marginal costs of the firm. Well, firm 1 always has marginal cost equal to 0 because firm 1 is the patentee, so it is the innovator, so the marginal cost of firm 1 are 0. Let me indicate by QIK-C2 and VIK-C2 the Cournot quantity and the profit of firm I respectively when firm 2 has marginal cost C2, where C2 depends on whether firm 2 has a license or not, and depends on the licensing policies. What about the licensing policies we are considering? As I told you at the beginning, we are just focusing on 2 kinds of licensing policies and combinations of them. The first one is the so-called per unit royalty scheme. Basically, here, what you have is that when firm 1 licensing the innovation to firm 2, with unit royalty R greater than 0, firm 2 has no production cost anymore, but clearly it has to pay the royalty to firm 1, so its effective marginal costs are R, because they are the per unit that firm 2 is paying to firm 1. And so the payoff of firm 1 are given by the sum of its Cournot profits and the royalty revenue. In the case of the fixed fee, instead, firm 2 is paying a fee which is not dependent on the quantities producing, to firm 1. And the maximum fixed fee that can be set by firm 1 on firm 2 is given by the difference between the profits of firm 2 in the case of the license, so when the marginal cost of firm 2 are 0, minus the profits of firm 2 when it has no the license, so when the marginal costs are equal to C. And in this case, the payoff of firm 1 are the sum of its Cournot profits and the fixed fee. So what about the structure of the game? So the strategic interaction of the game is the strategic interaction between firms 1 and firm 2 is the standard one. So it is a 3-stage licensing game, where in stage 1, the patentee decides whether or not to license the innovation to firm 2, and it decides whether to use, in the case of licensing, whether to use per unit royalty or to use fixed fee. Then in stage 2 of the game, firm 2 decides whether or not to accept the licensing offer of the patentee. And finally, in the last stage of the game, the two firms compete in a duopoly style, and payments are made according to the licensing scheme that has been proposed by firm 1 and then accepted by firm 2. Here I just provide some pictures that represent visually the optimal royalty and the optimal fixed fee and the comparison of them. Because the solution of the model is quite easy because it is a standard. Of course, we can provide the proposition, but I think that it's better to see directly on the picture the result. And so this first picture represents the comparison between per unit royalties and no licensing. So not fixed fee, just comparing per unit royalties and no licensing. What we have here is a standard result, basically. What we have is that in the case of non-drastic innovation, so the left-hand side of the picture, the optimal per unit royalty is C, which is the level of the marginal cost in the absence of licensing. In the case of the drastic innovation, if K is lower than 1 divided by 2, the optimal per unit royalties are equal to 1 divided by 2, whereas if K is sufficiently high, then not licensing is better than per unit royalties. In the next picture, we compare optimal fixed fee with not license. Here the comparison is a bit more tricky, but what we have basically is that when the marginal cost is sufficiently low, then a positive fixed fee is always better than not license. When the marginal cost is sufficiently high, then fixed fee is better than not license only if K is sufficiently low. But when K becomes sufficiently high, then not license is better than fixed fee. And this is just for the comparison between each of the two types of licensing scheme with the case of no license. Then we have this picture that summarizes the comparison. Here is the comparison between per unit royalties and fixed fee, and of course no licensing. And what can be seen from this picture is the following. When K is sufficiently low, fixed fee turns out to be better than per unit royalties. And this happens both in the case of non-drastic innovation, so when C is lower than 1 divided by 2, and when we have drastic innovation, so when C is greater than 1 divided by 2. So what we are saying here is that, well, you might have that fixed fee is preferred to per unit royalties, even if the patentee is an insider, so it's competing against the licensee in the same industry. This happens provided that the capacity constraint of the patentee is strong enough, so K is sufficiently low. And you have this both in the case of non-drastic innovation and both in the case of drastic innovation. Clearly, If you are in the case of drastic innovation, so C greater than 1 divided by 2 and K is greater than 1 divided by 2, so which means that the capacity constraint is not binding, it's never binding, because we call that the monopolistic quantity is 1 divided by 2. So when the capacity constraint is not binding and you are in the area of drastic innovation, no licensing is better than both per unit royalties and fixed fee. Here we have a sort of intuition. We have to think more about it. The intuition of this result is the following, basically. Under pure fixed fee, the patentee and the licensee have the same marginal cost. So the revenues from licensing come from the fee required to the licensee. At the opposite, under per unit royalties, the patentee maintains the cost differential with the rival, and it gets additional revenues from the royalty. So basically, you have that when the patentee is an outsider, it doesn't care about the cost differential with rival because it does not compete with the rival. And so fixed fee tends to be preferred. At the opposite, when the patentee is an insider, it is important for the patentee maintaining the competitive position with respect to the rival. And so unit royalties tends to be preferred because per unit royalty maintains the cost differential by means of the per unit royalty, not by means of the production cost, but by means of the per unit royalty. This was the intuition in one paper, basically. So what we have here is that when K is low, the output produced by the patentee is low, because when K is low, capacity constraint is relevant. So therefore, firm one doesn't care about its cost advantage over the licensee, and indeed fixed fee tends to be preferred. The opposite, when K is high, the quantity produced by firm one is high too, because the capacity constraint is not so relevant. So cost differential tends to be important too, and so per unit royalty tends to be preferred with respect to the fixed fee.
Stefano, can I just give you an alternative, explanation?
Yes.
Yeah, I think.
Sorry, I'm not seeing who is talking. Debapriya.
Sugata.
Sugata. Okay.
Yes. Yeah. So basically, what you are finding here, when K is low, then the patentee becomes a kind of de facto outside innovator.
Yes.
Right.
Yes.
Because it's producing too less, right? So that's why fixed fee result coincides with the existing result in the literature.
Yeah.
And when the K is high, then you become a de facto mode of insider patentee, and then the royalty sort of becomes optimal.
Yes. Yes. This is the point. Indeed, what we have in this model is basically that K. It's like a bridge between the case of an outside innovator and an inside innovator. The closest K with respect to 0, the more this model is close to an outside innovator model. The higher is K, the more this model is close to upper unit to an inside innovator model. So it's not surprising, this result, of course.
Yeah. Let me say, anyone?
Yes.
Let me suggest something. Georgios, you want to make a remark?
Yes. I don't know who is talking first. May I ask?
It doesn't matter. Go ahead.
Can you tell us whether the profit of the licensor is increasing or decreasing in K?
You are making a good point. I don't know. Probably Deba knows the answer. I don't know. I don't remember the answer.
It's not important. It would be interesting to know whether something negative, a small K, might increase your profit because it changes your licensing policy in the one or the other direction. So maybe that has a counterintuitive effect. I don't know.
You can burn some capacity in front of everyone to make it common knowledge that you have less capacity.
Yes, could be optimal. Then.
Yeah, good point. Let me ask you a question. Sorry, Stefano, go ahead.
Okay, I think that your question is connected to a point that would like to develop more in this paper, because what we assume in this paper is that K is exogenous. Okay, so we assume that you have this exogenous capacity of the patentee. It might be interesting to endogenize the level of capacity. We have done some preliminary analysis of this, and it seems that profits of the licensor of the patentee should be increasing with K. But first, I'm not sure about this, and we have to think more about that. So it's probably that if we endogenize a capacity constraints, it's turned out that if possible, so if the cost of enlarging the capacity is not too high, the patentee would like to tend to increase the capacity constraint. But we have to think about it, of course.
Thank you.
Okay.
I want to
I
make
don't know whether.
You see, when you have a duopoly, it's really a bargaining problem between the patent holder and the other firm, as I see it. Therefore, it would be interesting to even to check, let's say that you put as a bargaining set, the entire, I mean, all possible using either royalty or using a fixed fee, or, I mean, all the possibilities, and to check what would be the Nash bargaining solution, for instance, to this case, because to assume that the patent holder has the power with two, I mean, to take it or leave it, that's the assumption behind the.
Yes.
It's a little bit, if you have many, I understand, but if you have only one, it looks to me more like a bargaining problem, and I'm pretty sure it's very doable. But then you take, not just compare royalty to fixed fee, you take all the possibilities, you find out what is the one.
Yes.
I mean, what would be the outcome? Is it a royalty, a fixed fee, or whatever?
A good point.
Can I ask a slightly different, but you know, this is not just regarding your model, but in general, all the models that we have seen in this session or yesterday. The question is, what if you introduce uncertainty and incomplete information into these models? You see, if you don't know exactly much about your competitor, and then is there literature in that direction?
Yes, is
A
there
lot of
literature
literature about that.
Huh?
Yes.
What? Sorry.
Yes, there is a literature.
literature.
There is also a recent paper by Yair and CU on it's not on complete information or risk aversion.
No, that's uncertainty, something else. He said he's talking about asymmetry, asymmetry of information. For instance, even the patent holder doesn't know the value of his invention, or the other party doesn't know. He knows the other one. So, but there are a lot of papers about.
Yeah,
no, I was not. I was talking even with symmetric uncertainty. Without asymmetry, you can still model uncertainty. So I guess I'm asking in general: symmetric, non-symmetric, uncertainty, incomplete information.
Uncertainty. There are.
What is known in general about these cases? Yeah.
So Siu Ma and myself, we just published a paper about uncertainty and risk aversion of the patentee or the firms. Look, there are thousands of papers on innovation by now. Mm-hmm. And it calls, by the way, in my opinion, to a big solver. It's very difficult to survey. It became huge.
Okay, but the basic idea that fixed fee is good in some cases, and outsider and royalty with insider, those results are sustained, robust to incomplete information and uncertainty, or not?
Not always. They are not so
not always.
Not always.
Not always.
I see.
Even that result is also not, even for outsider innovator, fixed fee is not uniformly superior.
I see.
Yes. So
yes,
it depends.
Yes, there are results like that. Yes.
For large N, a royalty can be superior.
For what? Sorry,
for large enough industry, for when N is large, relatively large, unit royalty can be superior even for outside innovator.
Once you introduce uncertainty in the model.
Even without uncertainty, even without.
I see.
This is the result of SEN 2005 in GB. Yeah. So tell them what is your result, because it's very interesting one.
So the result was simple. So what happens if you recall Naoki's talk, there was this cutoff of epsilon divided by elasticity of demand, which was the threshold beyond which you know, all the non-licenses drop out. Now, the problem is that that cutoff may not be an integer. So it's integer for, you know, it's rarely an integer. Like if you take any epsilon, it is most likely not an integer.
Yeah.
So that means that if you want to implement a fixed fee policy, you cannot do it because it's not an integer. And then it turns out that for large n, royalty can be better for generic magnitudes of the innovation, because it is generally not an integer. So that was
provided that you have sufficiently many firms in the industry.
So this is without uncertainty.
It is without uncertainty.
Without.
Once you introduce uncertainty, are you telling me that anything can happen? We don't have any patterns, any you know, general things we can say? What can you say?
With uncertainty, royalty, like there are results where, you know, if there are two components, fixed fee and royalty,
yeah,
one can use the royalty to offer a separating contract. Like suppose the innovator does not know the cost of the farms, it can be high or low. So the royalties can be used to offer a separating contract. So there are results of that kind.
Okay. I'm sorry, I'm asking it as an outsider to the profession. You are the insiders.
Pradeep, let me add that at the previous version of this conference many years ago, I presented a paper on uncertain patents. So a patent can be upheld if taken to court only with probability P, and that suffices. So this is uncertainty through the strength of the patent.
Okay.
And that suffices to reverse the result about the superiority of the fixed fee.
I see.
You can then have royalties being superior to fixed fee in the basic comparison.
I see. Okay, very interesting.
Yeah, if I can just add one more thing, Pradeep, I think if you change the framework from a conventional Cournot and Batra framework to a special competition, special framework, then you can also get a reverse in the, you know, in the out result. So there you can have, you know, royalty even with the outsider patentee. So the framework also matters.
But Pradeep, don't be surprised, because in reality, you see so many contracts. Some of them ad valorem royalties, some of them upfront fee, two-part tariff and everything. So it suggests that it depends on the model. It depends on what type of innovation it is, what type of uncertainty or incomplete information. You get different one, and that's what you see, variety of contracts in reality. You try to see what fits to what.
And I just want to add another point, another dimension, that the things also change when you have like a vertical structure between input supplier and the final goods producer. They are interacting, and then you consider licensing. So that can also change the results. Stefano, just I want to add two comments actually quickly. The type of, I mean, I have a paper in economic theory in 2001, which is somehow related to your paper. I do not have any comparison of royalty and fixed fee, but I have this capacity constraint. And actually I have, as Pradeep was mentioning, that I have the capacity constraint for both firms. And actually it was more like an endogenous capacity commitment. And I considered both simultaneous and sequential capacity commitment, and then considered the profitability of fixed fee licensing. So that might be relevant for this one.
Yes, thank you.
And another paper I have in Journal of Economics with increasing marginal cost, convex cost, with two-part tariff licensing. So that is also giving some amount of that capacity constraint type of flavor.
Okay, thank you.
In you have strategic interaction there? Just remind me.
Yes, yes. Yeah. So it's basically the Cournot model.
Huh?
Cournot models.
With a duopoly or oligopoly?
No, the economic theory is duopoly, and the other one is oligopoly. Journal of Economics is oligopoly.
Okay, don't remember it, but I'll look at it. By the way, the paper that CUMA presented yesterday, jointly with Debapriya and myself, about three-part tariff, taking all the instruments into account, you get variety. You can get a lot of optimal policies, licensing policies. The one that she showed that it's enough to look on upfront fee plus per unit royalty, even though in reality you see a lot of ad valorem royalty in the sense of ad valorem revenue royalty, percentage of revenue. And she shows that there is necessary and sufficient condition where you have two-part tariff with this. And by the way, in the paper, it says something about when you expect to use that one, or when sometimes for different type of products, it's more practical to use ad valorem royalty than to use per unit royalty. So the variety says that, Pradeep, you cannot expect one general result. The optimal one, you may have variety of optimal one, and you use them depending on the specific one, which is most practical to use.
Okay, thank you. Now, let me discuss quickly the case of the combination of unit royalties and fees. Let's consider the last line. Here you have the payoff of firm one. So they are this, in this case, they are the sum of its Cournot profits, revenue royalty, which is the second term, and the fixed fee, which is the combination of the third and the fourth term. Okay, so you can see that the profit of the income of the patentee does not depend on the last term, because this is related to C, which is the marginal cost of firm two. So the last term is constant. So the problem of the patentee in this case is to choose R, so the per unit royalty, in order to maximize the first three terms. And rewriting the first three terms, what you have here is the monopolist profits at price PKR. So in the case of an optimal combination of royalties and fixed fee, the problem of the patentee turns out to choose the royalty R that maximize the monopolist profits. By using this rewriting of the patentee profits, it can be shown that the optimal combination of royalty and fixed fee for the patentee has the following shape. So basically what you have is that in the case of non-drastic innovation, if K is sufficiently high, so above the red line, what you have is a pure per unit royalty, where R is equal to C and fixed fee is 0, so per unit royalty. But when K is sufficiently low, so below the red line, what you have is that fixed fee is positive, and the optimal per unit royalty is equal to K, which is lower than C. So this turns back to the result I said at the beginning. So in the case of a capacity constraint and optimal combinations of royalty and fixed fee, we have that there are cases where the optimal royalty is lower than what you have without capacity constraint. Because here we have that R is equal to K in many situations and not R equal to C, as in the case of no capacity constraint. This is connected to the last picture too. Here we have an analysis of the excess capacity under optimal combinations. And what we have is that when K is low, clearly the capacity constraint becomes binding. And so there is no excess capacity below the red line. Above the red line, there is no excess capacity. Sorry, there is excess capacity. So the quantity produced by the patentee is lower than K, lower than the constraint. And this is connected to a welfare analysis, which is summarized in the last picture, which is very easy. What you have is that when you are considering optimal combinations of per unit royalties and fixed fee, welfare is increasing in K when there is no excess capacity. So let's turn back to the previous picture. Yeah, when there is no excess capacity, welfare is increasing in K. When clearly there is excess capacity, welfare is not dependent on K. So welfare is a constant on K. But for low levels of K, what I'm saying here is that for low levels of K, welfare is increasing in K. And that's all. So what the conclusions of the paper? We have a standard Cournot duopoly licensing game with capacity constraint patentee. This is what we have done. We have considered a very basic licensing model, a duopoly with Cournot competition, and we introduced in this a capacity constraint patentee. We compare fixed fee and per unit royalties, and we consider also combination of them. There are further issues we have not considered here. There are many issues we have not considered here. Other licensing mechanisms, endogenous capacity, oligopoly instead of duopoly, non-linear demand, incomplete information, and so on and so on and so on. So this might be considered a starting point, basically, a big step on the literature. So just extending the basic model to the case of a capacity constraint patentee. But since no one has discussed about it, so we think that it might be interesting, even if it's very simple. Okay. That's all, and thank you for the attention.
Stefano, why not to start with the symmetric case, where both of them have the same capacity constraint? Why to make it?
Well, I think that it might be more realistic, assuming that there is asymmetric capacity constraint, because after all, we are considering two firms which are asymmetric ex ante. One is an innovator and the other is not an innovator. Assuming that they have the same capacity constraint, well, it's like to say, well, they are different because one is able to innovate, the other is not, but they have the same capacity. I prefer assuming.
No, but then by increasing your royalty, if I'm the innovator, I'll make. I'm probably going to the capacity limit. And you are not, because you produce less.
Yeah.
So it's interesting. I mean, to check. I don't know. Maybe it's trivial, but I would. If you ask me, I would first start with the case where both of them have the same capacity, and then I mean they have the same technology, like in most of the literature, and then you have some cost-reducing innovation. So it's a oligopoly with even N firms. All of them has the same capacity constraint, and then there is innovation. I think that really will extend the literature, because if K is very large,
this might be easier. Yes, if you want to move to oligopoly, then yes, it might be easier, assuming that they have the same capacity possibilities. That's why it becomes quite complicated, because even a model like this, which seems very simple, then it becomes quite cumbersome to solve when you have to consider the constraints. So it's easy to explain it, but the proof is very long and
so connected with both your points, I again ask a naive outsider question. You know, you implied in the beginning that empirically it is the case in this real world that a lot of innovations are happening from small firms, not from large firms. And though the large firms could easily create their own R&D. So in the industrial organization literature, is there some theoretical explanation of this empirical fact? And where is it coming from? What does it intuitively come from? Can you tell us? Anybody? I'm asking the whole community of experts sitting in front of me.
This would be very useful for us, having such an information. So if some of you has an intuitive explanation of this, it would be very important.
First of all, is it empirically true? Even that I don't know, that more research, or innovation comes from small firms, not from big firms. Is that a fact? I don't even know that. If that is a fact, then is there a theoretical explanation?
Let me tell you, about 50% of innovations are coming from labs outside of outsiders.
Mm-hmm.
Okay, so would you consider this? And it really depends on the field. I'm saying pharmaceutical is not for small ones. High tech, usually you don't write a patent and you don't license. Typically, not. So it really depends. I don't know.
Okay.
You know, we're theoretical people. Don't confuse us with reality.
No, you are wearing both hats, guys. So I'm asking all of you.
Yeah, no, I don't.
Literature that argues that size is an advantage to innovation, but I don't think the results are robust across industries. And you have a lot of industries where the large firms tend to buy small innovating firms. So the question becomes a bit confused.
Yes, but then the large firms are finding it more efficient to just let the innovation be done by small ones and then buy them up. So
that's what I just said. Yeah. So you have that observed phenomenon as well. So when you have that, then it's not so clear how you answer the question, because small innovating firms do get bought out by the big firms.
And moreover, sometimes the big firm put the innovation on the shelf. They don't use it, but they want to make sure that for them it's not very important, but they want to make sure that nobody else uses it.
And it's a bargaining chip in case of litigation. It's like, I'm just adding to what you said, Yair. It's sometimes the big firms innovate and they keep it on the shelf just as a bargaining chip in case they get litigated.
Yeah, that's another topic. You are an expert on that.
Yeah. Or it could be an option value, like you do not know the value right now, you shelve it, but maybe after 10 years, that the value realizes. So, that could be an option value, why you shelve the technology. So there are variety of, reasons why this thing happens.